Alright, so as I given this diagram here where you have a puck on an air hockey rink, and the question says, puck slides on a frictionless air hockey table. It is acted upon by a conservative force described by this function here, where r is equal to the distance from the puck to the origin. Find a vector expression for the force, and find the magnitude of the force vector. To start, we know for a conservative force, the force is equal to this, where u is the potential energy function, and r is the direction of interest, which could be x, y, z, any direction. So we can apply this to our example. This is our example here, and this is our potential energy function. The first thing we gotta do is to identify what r is. And if we look at our potential energy function equation, we have two directions that the potential energy acts on, the x and the y. So our equation for the force can be transformed into this, where f of x is this term, and then f of y is this term. So the next thing to do is define what force x and force y is. And we can start by finding what force x is by applying the potential energy to this equation. And if we do that, we can start by distributing the 1/2 k into each term, and then we can distribute the partial derivative to each term, and we get this. And then we can identify the right term is equal to 0, since we can assume that y is constant since we're taking the derivative with respect to x. And so we're just left with this, and then we can take out the 1/2 k because it doesn't depend on it, and then we can use the power rule, which is given by this. And so we identify that in our case a is going to be equal to 2, and if we use the power rule we get this answer for the derivative, so we can plug that in and we get this final answer here for the force in the x. We can use this equation for the force in the y, and by the same process of plugging in u and deriving, we can find this answer for the force in the y. In general, the force vectors can be written in this form here, where f of x and f of y are the magnitudes of force in the x and y direction, what we just found, and I and j are the unit vectors pointing in the x and y direction. If we plug in the values we just found, we get this. So this is the force vector for the potential energy function given. To find the magnitude of the force, we can use the Pythagorean theorem. To draw our hockey puck here, the force in the x is going to be pointing in the negative kx direction, and then the force in the y is in the negative y direction, and so it looks like this. The magnitude of the force is going to be our total displacement. We can use the Pythagorean theorem to find it. So it's going to be equal to the square root of the square of both sides. And if we plug in our values and simplify, plugging in r is equal to square root x squared plus y squared. So we get this for the final answer, and this is the magnitude of the force vector, where r represents the position vector relative to the origin of the puck. If we take the origin to be here, the force vector is always going to be pointing towards the origin. And this makes sense because the force vectors fy and fx are negative, so that means it's an attractive force. So the hockey puck is always going to be attractive towards the origin.